Everyone, welcome back to the Frontend Insight. So, have you ever wondered how Angular becomes one of the most powerful front-end frameworks in the world? Let's rewind the clock. From its humble beginning in 2010 to the high optimized Angular 20 we see today. This is the complete journey of Angular's evolution. Okay, so the beginning, AngularJS 1.x. It all started in 2010 when Google introduced AngularJS or simply Angular 1.x. Back then, web development was mostly about static pages and server-side rendering. But AngularJS changed the game. With features like two-way data binding, dependency injection, and custom directives, it gave developer a new way to build dynamic, interactive, single-page application right in the browser. So, for many, AngularJS was love at first sight. It was declarative, flexible, and made development much faster. But as application grew in size and complexity, AngularJS started to show its limitations. Performance becomes an issue. The digest cycle, though innovative, struggle under heavy loads, and organizing code become increasingly difficult, so especially for large enterprise applications. By 2015, it was clear AngularJS needed a complete overhaul. So came to Angular 2. Unlike an update, Angular 2 was a full rewrite from the ground up. Gone were control and gone were controllers and at the rate scope. In came component in came components, TypeScript, and a modular architecture. Angular 2 introduces a cleaner component-based structure similar to React, but with Angular's own flavor, dependency injections, RxJS for reactivity, and emphasis on maintainability. But this transition wasn't easy for everyone. Moving from AngularJS to Angular 2 felt like learning a whole new framework, and it required serious efforts. Despite this, Angular 2 laid a solid foundation for the future. Then came Angular 4. What happened to Angular 3, right? It was skipped due to version mismatch in the router package. So the team jumped directly to Angular 4 in 2017. This version brought smaller bundle sizes, better compatibilities with TypeScript, and Angular was finally stabilized. From this point on, Angular started to follow a particular predictable release cycle, 2 major updates per year. Angular 5 focused on performance improvement. Angular 6 brought Angular elements, allowing Angular components to be used as a native web components. Then Angular 7 gave us a virtual schooling and drag and drop support. Angular 8 introduced differential loading, automatically serving modern JavaScript to modern browsers and legacy code to older ones. This significantly improved the performance. But the real game changer came in Angular 9 with the release of the Ivy rendering engine. Ivy made Angular faster, smaller, and more debug friendly. It opened the doors to better build times, better error messages, and improved reshaping. Angular 10 and 11 continue refining the framework, enhancing linting, updating TypeScript versions, and polishing developers' tooling. The Angular CLI becomes a beloved tool for many developers, handling scaffolding, builds, testing, and deployment, all with just a few commands. Then the modern Angular version like 12 and 17. With Angular 12, the focus shifted to modernization. The team dropped support for legacy view engine, going all in on Ivy. There were updates to the compiler, improved strict typing, and enhancement in performance and accessibility. In Angular 13, Internet Explorer 11 support was dropped, marking a new era of cleaner and modern code. Then Angular 14 delivered something long-awaited, standalone component. For the first time, developers could create components without wrapping them in an ng module. This drastically simplified the learning curve and improved modularity. Then Angular 15 doubled down on this idea and making standalone APIs first-class citizen. In version 16, Angular introduces signals, of new reactive primitive designed to optimize change detections and improve UI performance. It also brought in support for server-side rendering, hydration, and non-destructive hydration. By Angular 17, the framework was faster, leaner, and more flexible than ever before. Okay, then Angular 18 and Angular 19 laid the groundwork for a new era of zoneless change detection. The Angular team started shifting toward fine-grained reactivity using signals instead of Jones.js resulting in more predictable and performant application. Improved documentation, better error handling, and better server-side rendering. Server-side rendering capability become the top priorities. And then came Angular 20, the latest and perhaps the most refined version of Angular so far. Angular 20 focused on polishing the Signals API, integrating it deeper into the framework and enabling the future-facing tools and optimization. It brought better debugging tools, lighter build outputs, and smoother developer experience out of the box. So at this point, Angular stands not just as a framework but a complete platform for building scalable, maintainable web application. Okay, so and then the conclusion, the like so what makes Angular special even after all these years is opinionated yet flexible. It's backed by Google and trusted by large enterprises. Its tooling in top notch, from Angular CLI to Angular Material to built-in testing support. Whether you're building a hobby project or enterprise grade web application, Angular has the structure, scalability, and support to back you up. As we look ahead, Angular's future seems bright. The push for zoneless apps, more reactive UI models, and tighter integration with modern web APIs means Angular is not standing still, it's evolving. So, whether you started your journey with AngularJS or just got into Angular 20, one thing for sure, Angular continues to shape the modern web and one component at a time. So guys, if you enjoyed this deep dive, give this video a thumbs up. Don't forget to subscribe for more tech content and drop a comment. What version of Angular did you start with? See you in the next one. Thank you.